So finally, under differentiation, we're going to be looking at higher derivatives, and this is really just a slight extension from what we've been discussing. So if you consider a function f of x being equals to y, then we know that dy over dx that we've been trying to find throughout our previous example is known as the first derivative. And when we are finding the first derivative, we differentiate just once. Now when we have d squared y over dx squared, so this is the general format, then we're talking about the second derivative. So what it means that we should differentiate this function 2 times. When it is cube, the cube y over dx cube, that is the third derivative, and it means we should differentiate y thrice. So now for any power of n, dny over dxn, it means that we should differentiate that function with n times. So pretty easy and pretty much what you already know, just that the number of times you differentiate is going to be different based on the derivative that we're trying to find. So let's try to look at some simple example to illustrate this point. So in this first example, we're told that if y is given by 3x power 4 plus 3x cubed plus 7x plus 3, told to find dy dx, the squared y dx squared, and the cube y dx cube. This is a type, here should be the cube y dx cube. So how do we, first and foremost, let's start off by solving dy dx. So I know that my dy dx will be equals to what? I bring this down, so I have 4 times 3, which gives me 12x, and since here is 4 minus 1 gives me 3, so 3 plus, I bring this 3 down here, so I have 3 times 3, which gives me 9, then x, then 3 minus 1 gives me 2, then plus 7x. When I differentiate it, I'm just going to be left with 7, and when I differentiate 3, which is a constant, it terminates to 0. So this is the first derivative. So now let's work out the second derivative. So d squared y over dx squared just means we should differentiate dy over dx again. And when we do that, we just bring this 3 down here. So I have 12 times 3, that gives me 36x, and 3 minus 1 gives me 2, then plus 2 times 9 gives me 18x, and x, 2 minus 1 gives me 1, so I have 1, and when I differentiate 7, I'm left with 0, so it terminates. So the third derivative, which is what? The cube y over dx cube, just means that I should differentiate the squared y over dx squared again. So when I do that, I have 36 times 2, which gives me 72x, then I'm left with plus, when I differentiate 18x, I'm left with 18. Now this is what the question asks us, but we can even extend this concept further. So as a side note, let's try to even find more higher derivatives. So what is going to be the 4y over the x is power 4. So now I want you to pause the video and try to solve it on your own. Now once you've done that, you should get, when you differentiate 72x, you are going to get 72, and 18 is going to terminate to 0, so you have what? 72. And we can even go further by saying the 5 power 5y over the x is power 5, and what do we get? Now when we differentiate a constant, we get 0. So the derivative, our derivative just means that we should differentiate more than once depending on the order. If it is order of 1, we differentiate once. If it's order of 2, we differentiate 2 times. If it's 3 times, we differentiate thrice. If it is 5 times, we differentiate 5. And if it is n, we differentiate n times. So now let's look at a final example to illustrate concept of our derivative. So we are told that y is equals to 4 cos 3x. We are told to find d squared y over dx squared. So I'm going to solve it using the longer method, and as you can see, this is a classic chain rule example. And how do we do that? So we say let u be equals to 3x. So this becomes y is equals to 4 cos u. So now I can find du over dx. So du over dx becomes what? When I differentiate 3x, I'm left with 3, and y dy over du becomes minus 4 sin u. Because differentiation of cos u will give me minus sin u, and I have before there before. So I know that my dy over dx will be equals to what? My dy over du times my du over dx, and that becomes minus 4 sin u times 3. So my dy over dx becomes what? Minus 4 times 3 gives me what? Minus 12 sin u. Now I can replace back my value of u as 3x. So that is the same thing as saying minus 12 sin 3x. So this is dy dx. So now we are going to try to differentiate this again, because the question asks us to find the value of d squared y over dx squared. But this time around, I'm not going to go through this long method. I'm going to do it directly, and you can try to solve it with the long method on your own to see if you arrive at the same answer. So d squared y over dx squared will be equals to, first thing I want to do is I want to take this coefficient and take it out, so I have minus 12. Then I want to differentiate what is here, and when I differentiate 3x, I'm going to have 3, and when I differentiate sin x, I'm going to have what? Cos x. So this becomes cos 3x. So that becomes minus 12 times 3 gives me minus 36 cos 3x. So that is value for d squared y over dx squared. So as you can see, this is pretty straightforward, and if you solve it using this approach that we did the first time, you are still going to arrive at the same answer. So as you can see, solving higher derivative is not really complicated. It just tells you the number of times you have to differentiate your function. So all the things we've learned before, the product through the chain rule, still applies. So this pretty much sums up our discussion on differentiation. So in the next section or next module, we are going to be looking at some past questions that are going to say how to apply the concepts that I've learned to solve practical JAMB questions, and this will really give us an idea of how to tackle questions that might come across in the exam. So that will be all for now.